The Thunus obesus, commonly known as the big-eye tuna or con nguchu in Vietnamese, is a remarkable and widely recognized species of tuna that has garnered attention from scientists, fishermen, and environmentalists alike due to its size, strength, and importance within marine ecosystems and commercial fisheries. This fish, which belongs to the family Scombridae, is found in the deep ocean waters of the tropical and subtropical regions across the globe. Noted for its deep, torpedo-shaped body and its unique characteristics, the big-eye tuna is not only a symbol of the power and resilience of oceanic life but also a critical species in maintaining the balance of marine food webs. The Thunus obesus is an apex predator, playing a vital role in the regulation of other fish populations. Its large size and high metabolic rate make it a highly efficient predator, capable of consuming a variety of smaller fish and squid. Its ability to reach speeds of up to 75 km per hour, 47 miles per hour, in short bursts also makes it one of the fastest fish in the ocean, adding to its reputation as a dominant force in the waters it inhabits. One of the most striking features of the big-eye tuna is its distinctive physical appearance, which sets it apart from other tuna species. It is characterized by its large, rounded eyes, which are adapted to the dimly lit depths of the ocean. The big-eye tuna's eyes enable it to navigate and hunt effectively in the deep ocean waters, where light penetration is limited. These large eyes are one of the species' most defining characteristics, contributing to its name and its ability to hunt in deeper, darker waters where other predators might struggle to see. The body of the big-eye tuna is sleek, designed for speed and endurance. It is muscular, streamlined, and coated in a dark, metallic blue dorsal side, which helps it blend into the deep waters above. Its ventral side is a silver white, which creates a counter-shading effect that helps it avoid predators and catch prey. This coloration is typical of many pelagic fish species and serves as an important camouflage in the open ocean. The big-eye tuna's size is equally impressive. It can grow to lengths of up to 2.5 meters, 8.2 feet, and weigh as much as 180 kilograms, 396 pounds, making it one of the larger species of tuna. This impressive size, combined with its rapid swimming ability, makes it a formidable predator in the open ocean. Big-eye tuna are found in warm, temperate seas, typically at depths of between 100 and 400 meters, though they can dive much deeper when searching for food. They have a broad distribution range, occupying the waters of the Atlantic, Indian, and Pacific Oceans. The tuna is highly migratory, traveling vast distances in search of food, and is known to move between different regions depending on the availability of food sources, water temperatures, and breeding conditions. These long migrations make the big-eye tuna an excellent model species for studying the migratory patterns and behaviors of pelagic fish. The big-eye tuna's migration patterns are influenced by environmental factors such as the water temperature and availability of prey. It is also an opportunistic feeder, capable of hunting a wide range of prey species, including squid, small fish, and even crustaceans. This dietary flexibility makes the big-eye tuna a key player in the ocean's food web, as it helps regulate populations of smaller marine organisms, contributing to the health and balance of the ecosystem. In the wild, the big-eye tuna's primary food sources include various species of squid, which form a significant part of their diet, along with smaller fish such as sardines and anchovies. These tuna are fast, agile predators that rely on their speed and endurance to catch prey, often engaging in high-speed chases to corner and capture their food. Their large eyes and keen vision also enable them to hunt efficiently in the depths where light is minimal. Their hunting strategy is generally to chase and capture prey that is unable to escape their speed and power, and they are capable of covering long distances in pursuit of food. Additionally, big-eye tuna are known to be opportunistic feeders, meaning that they will readily take advantage of whatever prey is available in their environment, including small fish, krill, and planktonic organisms. This ability to adapt their diet to available food sources is part of what makes them such a successful predator in the open ocean. Big-eye tuna's reproductive habits also contribute to their prominence in marine ecosystems. They are known to spawn in the warmer tropical waters of the Atlantic and Pacific Oceans. The spawning season for big-eye tuna generally occurs during the summer months, with the female releasing large numbers of eggs that are fertilized externally by the male. These tuna are prolific breeders, and the high number of eggs produced ensures that, despite the many threats they face from predators, fishing, and environmental changes, the species continues to survive and thrive in the wild. The fertilized eggs hatch into larvae that drift with the currents, gradually growing into juvenile tuna that begin to assume the characteristics of adult big-eye tuna. The young tuna go through several stages of growth before reaching maturity, and during this time, they must avoid the many predators that inhabit the open ocean. Predators of the big-eye tuna include larger fish, such as sharks, marlins, and other tuna species, as well as marine mammals like dolphins and seals. The big-eye tuna's size, speed, and aggressive behavior help protect it from many of these predators, but it is still vulnerable to predation, particularly when it is young. The relationship between the big-eye tuna and its environment is complex, as the species is affected by a variety of environmental factors, including temperature changes, food availability, and the health of the ocean ecosystem. Climate change, overfishing, and habitat destruction are all significant threats to the big-eye tuna population. The warming of ocean temperatures, for example, can alter the distribution of prey species and may push the tuna into areas where food is less abundant, forcing them to migrate farther in search of sustenance. Overfishing also poses a significant risk to big-eye tuna populations, as they are highly sought after in commercial and recreational fisheries for their meat, which is prized in sushi and sashimi. The demand for big-eye tuna has led to overexploitation of the species in certain regions, and the depletion of tuna populations has sparked concern among conservationists, who are working to implement sustainable fishing practices and protect the health of tuna stocks. Efforts to conserve big-eye tuna populations are ongoing and involve a variety of measures, including the establishment of fishing quotas, restrictions on fishing gear, and the implementation of marine protected areas. Organizations such as the International Commission for the Conservation of Atlantic Tunas, ICAT, and the Western and Central Pacific Fisheries Commission, WCPFC, are working to regulate the tuna fishing industry and ensure that tuna populations are managed in a sustainable manner. Additionally, some countries and regions have implemented measures to limit the number of tuna caught during spawning seasons, allowing populations to regenerate and ensuring the long-term survival of the species. Sustainable tuna fishing practices are critical to the survival of big-eye tuna, as well as to the overall health of marine ecosystems. For instance, implementing better monitoring systems, reducing bycatch, and using more selective fishing techniques can help reduce the impact of fishing on big-eye tuna populations. Furthermore, raising awareness about the importance of conserving tuna and promoting the consumption of sustainably caught fish are essential for maintaining healthy tuna stocks in the future. In addition to these direct conservation efforts, scientific research plays a key role in understanding the biology, behavior, and migration patterns of big-eye tuna. Researchers use advanced technologies, such as satellite tracking and genetic analysis, to monitor tuna movements, study their reproductive habits, and assess the impact of environmental changes on their populations. This research is invaluable in providing the data necessary to develop effective conservation strategies and ensure that the big-eye tuna continues to thrive in the wild. In conclusion, the Thunus obesus, or big-eye tuna, is a species of immense ecological and economic importance. It serves as an apex predator in the marine food web, helping to regulate populations of smaller fish and other organisms. Its impressive physical attributes, including its large eyes, streamlined body, and high-speed swimming capabilities, make it a remarkable and powerful predator. However, like many other marine species, the big-eye tuna faces a range of threats from human activity and environmental changes. Conservation efforts, sustainable fishing practices, and scientific research are critical to ensuring the long-term survival of this species. The future of the big-eye tuna depends on our ability to protect marine ecosystems, regulate fishing practices, and ensure that this iconic species continues to thrive in the world's oceans for generations to come. The big-eye tuna not only represents the strength and resilience of marine life but also serves as a reminder of the fragility of the ecosystems that sustain it.